Good evening everyone. Today we are going to study about the sign conventions for mirrors, right? And this is very important video which will help you to use the sign conventions while solving the numericals for concave mirror. Okay, so I have already made one video how to draw the ray diagrams for mirrors as well as for lens. I will give you the link in the description. You can watch it and then you can watch this video which will help you to use the sign conventions while solving the numericals for the mirrors. Okay, so we already know that there are two types of curved mirrors. One is concave mirror and the other one is convex mirror. Okay, I'll draw the diagram. This is the structure of the concave mirror, and for convex mirror looks like this. So I have already made one video. One video is already have been made. You can watch it, and let us learn about the sign conventions. Here, convex mirror, and this is a concave mirror. So let us learn the sign conventions for concave mirror. This is a concave mirror, and here a straight line which is drawn is called principal axis, and so above this line I have drawn an arrow. Okay, this arrow is considered as object. Okay, this is an object, right? And this point, midpoint on the surface of the mirror, curved mirror, is known as pole P. Okay, so here I have placed one object in front of the concave mirror, and from this point to this point it is called as the object distance. Understood? This is called known as object distance. Similarly, even for convex mirror also, this is pole, and I have placed another object in front of the mirror, and this distance is considered as object distance. So here it is object distance, and even for convex also object distance. So object distance, we use a letter which is letter U, even for convex mirror as well. So letter U is called as, like, will be considered as the object distance. If you observe here, object is opposite to the mirror. So object distance is always, the object is always opposite to the mirror. So we will take it as negative. Even here also, the mirror and the object both are opposite. So U value, U is nothing but object distance, will be negative. Okay, now as we all know that the ray diagrams, for coming to the concave mirror, we get two types of images. One is a real image, and the another one is virtual image. Okay, so to understand about real and virtual image, watch the video which I have already made for the ray diagrams. So if you observe, in this case, so one point we have learned is object distance will be negative always, even for both the mirrors, for concave mirror and for convex mirror. Okay, so I'll draw two diagrams. We know that this is pole, focus point, and center of curvature. Let us consider that this is the first case. I have placed an object here, where object between pole and focus point. So we know the rules to draw the ray diagrams. Light ray is passing parallel to the principal axis. This line is called as principal axis. So when it is passing parallel, after reflection it passes through focus point. Okay, this is one condition. And another light ray, I'll take it from center of curvature. Imagine that the another light ray is passing through center of curvature. So we observe that these both light rays are going to, here they are not going to meet. It is not possible because the distance is being increasing. But there is a chance they can meet at towards or behind the mirror. So what I will do is I will just extend these two light rays, and I have observed that both the light rays met at this point. At that point we will get the image for this object. So if you observe this, this is an object and here this is an image I have drawn with dotted lines. So this type of images are known as virtual images. Virtual image. Okay, and image is straight. We call, we use the term erect. Okay, for coming to the convex mirror, for convex mirror, wherever you place an object, anywhere, at any point, okay, at any point if you place, you will get the image always behind the mirror only. Even the object distance changes, the position of the object changes, but image will always, you will get here, sorry. So we need to locate the focus point pole, focus point and center of curvature. So always we get the image between P and F. So I have already made the video, you can watch it. So what do we understand is, in convex mirror, even the object distance changes, the position of the object changes, but we observe that we always get the virtual image. Virtual image. Now this is the condition for concave, and as I have already said that convex mirror always forms virtual image. Concave mirror forms, it is formed, the real image is formed. Another condition I will show you. So this is one condition. I will draw another ray diagram. So we have seen that concave mirror formed the virtual image. Virtual image is formed. Okay. Consider another condition for the ray diagram. Concave mirror, principal axis, pole, focus point, center of curvature. Okay. Let us imagine object is placed between focus point and center of curvature. Okay. So from here the light ray is passing parallel, and we know that if it is parallel after reflection, it passes through focus point. Okay. Now another condition, I will consider another light ray which is passing through focus point. So in the first case, parallel to the principal axis after reflection, passing through focus. The second case, passing through focus after reflection, passes parallel to the principal axis. So we observe that both the light rays will meet at this point. So if you observe in the first diagram, in the first case, in the previous diagram, image, this is the image formed at this side, but in the second case, image is forming right side of the mirror. So this type of images are known as real images. So one thing you should remember, concave mirror forms both virtual image and real image, but convex mirror always forms only virtual images. So as we all know that, you just observe that one image is towards downward direction, another image is towards upward direction. Okay. Now to remember this, very simple, very easy, as we all know that in mathematics, while we are drawing the graphs, these are the four axes. This is x-axis. Okay. This is x dash. This is considered as y-axis, and it is y dash axis. Okay. So and this is origin. As we all know that, towards this side we will take the positive values 1, 2, 3, 4. All positive values we will take on x-axis, and here negative values towards x dash. And coming to this case, y-axis, the upside, we will take the positive values, right? Plus 1, plus 2, plus 3, plus 5, and so on. And similarly, downward direction, we will take the negative signs, negative values like this. So what do we observe here? Upward direction I am taking as positive values, and downward direction we are taking the negative values. Understood? So this is how we use in mathematics, while drawing the graphs. Okay, same thing apply to this sign conventions also. So what do we observe here is one thing we have understood. Object distance is negative for both the cases. Now coming to the image distance. Okay, so image distance we will take it as negative. So what is the image? See, I will draw both the diagrams. So in this case, when I have placed the object between P and F, okay, image is formed like this. And in the second case, when I have placed an object here, okay, between F and C, so the image will get beyond C. Okay, so in this case, if the image, this is known as image. Okay, this is image, and here this is image and this is object. Okay, from here to here, this is known as image distance. It is called as image distance. Similarly, this is considered as object distance, and similarly from here to here, this is known as the image distance. So where the image is formed, from where we are considering the image distance or object distance? From pole. So what you remember, you should remember that all the distances will be measured from the pole itself. Okay, so image distance will be denoted as V. So V is equals to, so here if you observe, for concave mirror, this is also concave mirror, in one condition image is upward direction, in another condition image is downward direction. We remember the graph, right? Upward positive, downward negative. So there is a chance for image to get the positive images or negative images also, negative value. Okay, understood? Similarly, but what about in case of convex mirror? Convex mirror always forms the virtual image, which is always upward direction. So we will always take plus or positive. Okay, V value. Okay, fine. Now, so this is object distance. You may note down object distance U, V, image distance. Similarly, here also same. Okay, and you already know the terms, right? What are the terms we get? One is pole, focus point, center of curvature, and the distance from pole to center of curvature is known as radius of curvature R. Okay, radius of curvature R, and the distance from pole to focus point is known as focal length, small f, and here f to c is also small f. Distance is same. So 1 r is equals to how many f's? 2 f's. So 2f. This is the formula to find the radius of curvature. To find the focal length, when radius of curvature is given, the formula will be r divided by 2. Okay, this formula you should remember. Okay, fine. So another term I'll take it as focal length here, f value. Okay, focal length. First same here also focal length. Okay, and next term radius of curvature r, even for convex mirror r. Okay, one very simple trick I will tell you. If you observe here, in convex mirror, the last letter is x, convex. Okay, then let us consider like this. Suppose this is x. Okay, x. If I turn it, it becomes plus. Understood? When I turn it, it has become plus. So one thing you should remember in case of convex mirror, except u value, u means object distance, everything will be positive, positive. Understood? X in bracket you can write plus. So u is common, u is negative for both the mirrors. U is same, minus. And V positive, F positive, R value positive. And coming to the focal length here, we always get negative because it is towards the right side. And radius of curvature also right side. Right side, it means opposite to the pole, it is also negative. Clear? So how many terms we have learned? U, V, image distance, and F, focal length, and next R, radius of curvature. Okay, radius of curvature. Fine. Here also same. Now another important point I will tell you, another formula, magnification M. The formula for magnification M is equals to HI. HI means height of image divided by height of object, which is equals to minus V by U. Very important formula, you should remember. Magnification M is equals to height of image divided by height of object, which is equals to minus V by U. So HI means height of image, H naught height of object. Understood? What is height of image? Imagine that this is a concave mirror, pole, focus point, center of curvature. So I have placed an object here. So this height is called as height of the object, H naught. And what happened in this case? In this case, we will get the image here between F and C, beyond C. Okay, so this is called the height of the image, Hi. Okay, in one condition, if you place the object here, this is the height of object, and in this case, we will get the image at this point. This is known as height of the image. Understood? Clear, all of you? Okay. Now, so another term is magnification. Okay, so in case of concave mirror, I like here. So one more term we have learned. Magnification M value. M for concave mirror, okay, and M for convex mirror. So we have seen that magnification for concave mirror will form real images and virtual images. So in case of real image, suppose in case of for the magnification sign conventions, if image is real, then M value is equals to negative. Okay, suppose if image which is formed, okay, when which image is virtual, then M value will be positive. M is equals to positive. In case of what about in convex mirror, we always get the virtual images only. So M is equals to positive. Okay, understood? So one thing I told you to remember is plus convex mirror. In convex mirror, except U, everything will be positive. So here, if image it always forms a virtual image only. So that is very simple to remember. Okay, so radius of curvature negative, and what about M value? M will be positive when the object is when the image is real, and M will be negative M will be positive when object is virtual, not object, image, and M will be negative when image is real. So these are the sign conventions you should remember. Okay, so U is minus for both the mirrors, V value image plus minus. So when do we get plus? When we get the virtual images. When do we get negative? When should we use this negative value? When the image is real. Okay, and what about focal length? Focal length is always negative because it is towards the right side. Okay, right side opposite to the mirror. And what about radius of curvature? Radius of curvature is also opposite to the pole, right? Opposite to the pole. Here, principal axis, focus point, and center of curvature. This is called radius of curvature. So radius of curvature is also opposite to the pole. And what about PF, P to F? It is also opposite to the pole. That is the reason why we take the minus here. F minus, R minus, M value positive or negative, both. It depends on the conditions. Okay, so this is very simple sign conventions which will help you to solve the numericals. Okay, any doubt if you have, you can put it in the comment section. I will simplify more than this, and I'll try to make you understand. Okay, thank you. So in the next video, I'll do the numericals based on using the sign conventions. Then you will understand very easy. Okay, thank you.